Alright, so the next we're still covering rational functions. We're still graphing them, but now we're going to do slant asymptotes. Okay, so just a little refresher on the steps. We start off by factoring all the parts. Then we check to see if any holes exist. If a factor cancels out, we find the domain and the vertical asymptotes. We find the horizontal asymptotes if one exists. Now, you either have a horizontal or a slant. You're never going to have both. And the reason is when you have a slant, the degree of the numerator is greater than the degree of the denominator. By one, okay, only by one. There is no horizontal asymptote, but there is a slant asymptote, okay? You find the slant asymptote, you find the x and the y intercepts, and then you find a few more points and graph the function, okay? Let's go ahead and get to the examples. Okay, so here they give us x squared plus 3x plus 2, so our very first step is to factor. Okay, so I'm going to go ahead and factor the numerator. The numerator, let's see, so x times x gives me x squared, 2 times 1 gives me 2, and it also adds up to a positive 3. And then on the denominator, we have x minus 1, okay? Now, nothing cancels out because x plus 1 and x minus 1 is not the same thing, okay? So then for domain, we're going to go ahead and set the the denominator equal to 0 and solve for x. So x minus 1 equals 0. We add 1 to both sides, and we get x equals 1. So our domain is going to go from negative infinity to positive 1, and then 1 to infinity. Okay, and then for holes, we don't have any, so here I'm going to write none. Now my vertical asymptote was a factor that didn't cancel, so since nothing canceled, the x equals 1 from here is my vertical asymptote. Okay, so I'm going to go ahead and graph that already. So remember, it is an invisible line, okay? No, I'm doing it here, but it is an invisible line, x equals 1. That our graph never crosses, okay? So for horizontal asymptote, we look at the degree of the numerator, it is 2. The degree of the denominator is 1. So since 2 is greater than 1, for horizontal asymptotes, we have none. Okay? But we do have a slant asymptote. Okay? So when we have our slant asymptote, what we got to do is we take x minus 1 and we divide it into x squared plus 3x plus 2. Okay? So x times x would give me this x squared. So I'm going to go ahead and put an x there. Then I multiply x times x is x squared. X times negative 1 is negative 1x. And then we go ahead and subtract. So when we subtract, this turns into a minus and this turns into a plus. You have to distribute that minus sign. That cancels. 3x plus 1x gives me 4x. Okay, then we start all over again. We have an x and we need a 4x. So in order for us to get a 4x, it would be x times a positive 4. Now from there, you do not need to... you don't need to continue. You don't need to find the remainder or anything. That is going to be the equation of our slant asymptote. Y equals 4x. You know what? I'm going to go ahead and make this into a dashed line just because it's bothering me that I want you guys to think this is a real line. This is an imaginary line. Okay. The same thing with the slant asymptote. So it is 4x. Okay. The way we graph 4x is we find the slope. What? Why did I write 4x? It's x plus 4. What the heck? X plus 4. I have no idea. It's this right here. Okay, so our m, our slope is going to be 1 because remember there's an invisible 1 in front of the x. And then our b, our y-intercept is 4. So we begin at positive 4 on our y-axis and then we do a rise over run of 1 over 1. Okay, and this is my slant asymptote. Okay, remember this is an imaginary line that our graph follows. Okay. All right. So now the x-intercept. For the x-intercept, we set the numerator equal to 0. So here we have 2 factors for the numerator. We have x plus 2. We have to set that equal to 0. And x plus 1 equal to 0. So minus 2, x equals negative 2. Here, minus 1, x equals negative 1. Okay, so negative 2, 1, 2, and negative 1. Oh, why did it do that? Okay, good. And then our y-intercept. So for our y-intercept, we go ahead and take our x, and instead of x, we plug in a 0. Okay. Now it doesn't matter which part you plug it in, whether the factored form or the regular form. But if you do end up canceling something out, you obviously have to put it in the reduced formula. So I'm just going to put in the factored one. So 0 plus 2 times 0 plus 1 over 0 minus 1. And this is going to give me negative 2. Oh, right here. What? Alright, so now I'm going to go ahead and make my graph. My graph is going to look something like this. It's going to follow along my asymptotes, go through these 2 points, and then come back down. And then the other side is just going to be in this area right here. That's it. Alright, the next part. So here we have x to the third power minus 8x squared plus 12x over x squared minus 5x minus 6. So we start off by factoring. Okay, so I'm going to take out an x here, and I'm left with x squared minus 8x plus 12. And on the bottom, I'm going to make my 2 factors already. X times x gives me x squared. 2 times 3 gives me 6, but that's not going to, it adds up to 5, but one of them has to be negative. So if one of them was negative, it wouldn't add up to 5, or negative 5. So negative 6 plus 1, that would add up to negative 5. Okay. On the top part, let's see. We have x. I'm going to go ahead and set up my 2 parentheses. This is x minus 6, x plus 1. X times x gives us x squared. And then 4 times 3 gives us 12, but that's not going to work. 6 times 2, and then both of them have to be negative in order for us to get it to add up to negative 8. All right, so then on this one, we do end up getting this to cancel out, and we get x times x minus 2 over x plus 1. Okay, and this is going to be my reduced function. So remember, when we need our reduced function, we needed to find the y value in the whole. We needed to find our x and the y intercepts as well. Okay, and then the leftover factor in the vertical asymptote, that's going to be from your denominator. So that's when you start using the reduced function. Okay, now let's go ahead and find our domain. So here we're going to set both equal to 0, so x minus 6 equals 0, and x plus 1 equals 0. So here I do plus 6, and x equals 6. And since this is a factor that canceled, that means that my whole is at x equals 6. Okay, and we'll find the y value in just a moment. Okay, continuing on with our domain, we do minus 1, x equals negative 1, and this one is my vertical asymptote. Okay, that's the factor that did not cancel. So this one's a whole, and this one is my vertical asymptote. Okay, so I'm going to write my domain real quick. It goes from negative infinity to negative 1, because negative 1 comes first on the number line, and then it goes from negative 1 to 6. And then it goes from 6 to infinity. Okay? All right, so then from here, I'm going to go ahead and graph my vertical asymptote. It's at negative 1, so I'm just going to make my dashed line here. There you go. And then my whole, we didn't quite finish yet. We need to find the y value. So to find the y value, we go ahead and plug in, instead of x, we're going to leave it blank here, into the reduced function, like plus 1. Okay, so my reduced function, instead of x, I'm going to put in a 6. And so this gives us 6 minus 2 is 4, and then 6 times 4 is 24, divided by 7. Let me go ahead and put that in my calculator real quick. That gives us 3.4. So the coordinate or the location of the hole is going to be 6, 3.4. All right. So then from there, we're going to go ahead and graph that 1, 2, 3, 4, 5, 6, and 1, 2, 3.4. And I'm going to make an open circle to show that there's a hole in that location of the graph. Okay. Then horizontal asymptote, we look at the degree of the numerator. The degree of the numerator is a 3, and the degree of the denominator is a 2. So 3 is greater than 2. Okay. And it's greater than 2 by only 1 unit, okay? So only by 1. So because it's only greater by only 1 unit, that means that we have a slant asymptote, okay? So we're going to go ahead and take our function. I'm going to need a little more room on this one. So x squared minus 5x minus 6. And we're going to divide that into x to the third power minus 8x squared plus 12x. Okay, so we look at x squared times what is going to give me x to the third power. Well, x squared times x would give me that. So then I'm going to go ahead and multiply x times x squared is x cubed. Whoops. And then x times negative 5x gives me negative 5x squared. And then x times negative 6 gives me negative 6x. Okay, then I go ahead and subtract. And when I subtract, these negatives end up turning to a positive. So this cancels. Negative 8 plus 5 gives me negative 3x squared. And then 12 plus 6 is 18. Okay, and then from there, I go ahead and start over. I have an x squared, and I need a negative 3x squared, so that means I'm missing the negative 3. Once you get that, that's where you can stop, because this is in the form of y equals mx plus b, where m is our slope, so it's going to be x minus 3. That means our slope is an invisible 1 goes here, so m equals 1, and our y-intercept is negative 3. Okay, so I'm going to go ahead and graph this. My y-intercept is negative 3, so 1, 2, and 3. And then my slope is 1, so rise over run is 1. Okay. So let me just make my dashed line, because remember, this is an invisible line. Okay, you don't really see it on the graph for reals. We just make it there as a guide for us to follow when we are graphing. All right, so now that we got our slant asymptote in, we're going to get our x-intercept. Remember, we use the reduced formula. Okay, so we're going to set the numerator. We have 2 factors in our numerator in the reduced formula. We have x and we have x minus 2. So we set each one equal to 0. This one we have to solve for x because we already got it. And then this one plus 2 plus 2, that means x equals 2. Okay, these are 2 x-intercepts at 0, 0. And at 2, 0. So then from here we have 0, 0, we have 2, 0. Then for our y-intercept, we go ahead and instead of x, we plug in 0. Okay, into our reduced function. So 0 times 0 minus 2 over 0 plus 1. So f of 0 is equal to, the top is going to be 0, the bottom is going to be 1, and this just gives us 0. So it crosses through 0, 0. Okay, which we already have that point on there. So we're ready to graph. So let's go ahead and graph real quick. Oh, I went to, wait, that's ugly. Let me do this over. So it follows along the asymptote. It crosses through 0, 0, comes back around through this hole, gets close to the hole, but doesn't cross through there. It's just like it teleports or something. And then we go down here. We got a little curve in there also. And that's it. Thank you guys. We'll see you next time.